Welcome to Wanning's Aquatic Care, Health and Diseases vlog on Practical 4, which is the one on the API test kit, aka the only practical without any fish. First, we are getting a pair of gloves because lab safety is very important. PPE, and we'll be handling bacteria.
Wow, this is like surgeon simulator.
That is very true, video warning. Yeah! Okay, let me just speed up this part. This is the wrong culture. Now that we've gotten the bacteria culture we got from the deceased tilapia from the previous practical, whoa, that was a mouthful, we're headed back to our desk. Yes, that's Nabila. Now, video warning will go through the different colonies that we saw in our culture.
So we have 16 different colonies in our culture plate and 3 different species. 1, 2, and 3.
Just as an intro to this practical, I also read out the first paragraph of this practical's introduction.
The major characteristics which are observed include the following: culture characteristics, morphology, and staining, biochemical characteristics, as well as serological characteristics. These routine tests are done on bacterial isolates that are brought to the laboratory or isolated from samples collected from various organic organisms. These tests are valuable in the diagnosis of various infectious diseases. So we'll be doing an API 20E today.
Then go and ask somebody how you wear.
But before that, we'll be conducting the oxidase test.
With some salmonella that Mr. Glendon prepared. Yay! And on a piece of paper paper.
10 seconds later.
The result of our oxidase test was negative, and this is correct as the species of bacteria that we are testing, Salmonella, is an oxidase negative bacteria. However, we also let the test strip sit for longer than the required amount of time, which is way past. So like we left it for about a minute on the table, and this provided a false positive result, just so we know what a positive result would look like. And we can kind of see a slight purple or blue tinge on the paper. Okay, now we've got the API 20 test kit in our hands, and as I'm showing you the different sections which test for different products produced by the different bacteria, you can hear Mr. Glendon in the background telling us about it. A little bit of background information on this test strip is that it is a biochemical panel used for the identification and differentiation of members of the family Enterobacteriaceae. It contains 20 plastic mini test chambers that contain dehydrated media that are chemically defined compositions for each test. They usually detect enzymatic activity, mostly related to fermentation of carbohydrate or catabolism of proteins or amino acids by the inoculated organisms. In other words, each test chamber will help to review whether the bacteria that we are testing produces this substance that is unique to the different species, and that can help us identify what species of bacteria it is. Now we will be preparing a bacterial suspension with the salmonella that Mr. Glendon prepared. And in my hands here is a tube full of saline solution. To that we'll be adding a hefty loop of salmonella bacteria, and then it should form. After vigorous mixing, roll Mr. Glendon's example clip here.
Vigorously shake the thing. Yes, vigorously.
It should become a cloudy mixture.
I'll be adding it into my saline solution now. Yes. Clearly you can see that the left one, saline solution without bacteria, is clear, and the right one, the one that I've been shaking, is cloudy.
Here I am transferring the bacterial suspension into the API 20 test strip. In this scenario, we do know that the bacteria provided is Salmonella, but normally we wouldn't know the bacteria, so we would be putting the unknown bacterial suspension into the test strip, and then based on the results of the color change in the test strips after a day, we will be able to identify which bacteria it is. So here I am transferring our bacterial suspension into all of the wells, just under the cupule, which is the opening of the well. I'm ensuring that there is no contamination by not allowing the dropper to suck back any of the bacterial suspension that has already been pipetted into the well. Certain wells that are specially marked with either a bracket or an underline would have to be filled to the brim with either more bacterial suspension or paraffin oil. This depends on whether the wells hold aerobic or anaerobic reactions. So the test strip is laid flat, and then those with brackets would be filled to the brim, which is the very top of the capsule, with more bacterial suspension, and those that are underlined will be topped up with paraffin oil. This would create an environment without oxygen so that the anaerobic reaction can occur. Now we are preparing the incubation box by filling the bottom with distilled water to create a humid environment. So once the API test kit has been filled with the appropriate reagents, which would be the bacterial suspension or paraffin oil, it is carefully placed into the incubation box and then left for 24 hours before we add our final reagents to get the final results. According to Mr. Glendon's standards of who clubs and who doesn't, I clearly would not be a good bartender.
Too much water, yeah.
So it's been settled. It's sufficiently deep. Ta-da! We're done! Yay! We'll get the results tomorrow in 24 hours. This will be incubated now.
So 24 hours later, we are back in the lab, and now we're adding the second day reagents. We are adding 1 drop of James reagent to IND, also known as the indole test, which tests for the production of indole from tryptophan by the enzyme tryptophanase. 1 drop of VP1 and VP2 to VP, also known as the Vokes Proscour test, for the detection of acetoin produced by the fermentation of glucose. And 1 drop of TDA reagent to TDA, also known as tryptophan deaminase, which is the detection of the enzyme tryptophan deaminase. This is the API test strip before we added the day 2 reagents, and this is the test strip after we added the additional reagents. So here are the final results of our API 20E test strip. So I can go through the results with you one by one. So on the left side, positive results will be interpreted as any color other than colorless or yellow. And on the right side, anything other than colorless or blue will be positive. So yellow color would be a positive result on the right side, or it would be a negative result on the left side. Okay, so starting from the first one all the way on the left is ONPG. It is a colorless result, so I would consider that negative. ADH has a tinge of orange, so I would consider that positive. LDC is a deep orange, so positive. ODC is a hot pink, so positive. CIT is an ombre color from blue to yellow, but I would consider that as positive. H2S is a black color, so positive. URE is yellow, so negative. TDA is a deep yellow, but yellow nonetheless, so negative. IND is colorless, so negative. VP has a tinge of pink, however, when looking at some brochures regarding the interpretation of the API results, a slight pinkish color is okay, as long as it is not a obvious pink. So this would still be considered a negative result. Okay, moving on to the right side, GEL is colorless, as the black portion in the middle didn't dissolve or anything, so this would be a negative. GLU is a positive, as it is a yellow color and not a blue or colorless result. MAN is yellow, so that's positive. INO is also yellow, so that's positive. SOR yellow, so that's positive. RHA is yellow, so positive. SAC is blue, so that's a negative. MEL is yellow, so that would be a positive. AMY is blue, so that would be negative. ARA is yellow, so that's positive. And there's one more result on the piece of paper in this triplet column. It is for oxidase. So earlier during our oxidase test, we got a negative result, so that would be negative. Now I'll show you an image of the piece of paper that we're supposed to fill in with the results, and any result that is positive means that we have to add the number in the appropriate well together with the other positive results in the same triplet column to form a number, and each column will form one number, and this will add up to a 7-digit code. So this 7-digit code can be used to find out what the bacteria species is by comparing it to the API database. However, because I do not have an account to enter the API database, I had to compare these results to a journal study that was like comparing samples from raw food items to check for the presence of salmonella, and they also used an API 20E test strip. And so my results match with theirs, in that the final code is 6704752, and this means that the bacteria is Salmonella spp, which is correct because we knew that our tested bacteria is Salmonella. The sum of all the numbers is also 31. With that, we have come to the end of my vlog. Thank you for watching!